To wrap this up, let's take a look at how to solve and graph a compound inequality. Now, sometimes you'll see the word and or written, and then other times you need to identify, is it really an and? Now, when you see an algebraic expression like 2x plus 3 sandwiched between two numbers, that is an implied and inequality, okay? You need to know that that means and, okay? It's basically saying negative 7 is less than 2x plus 3 and 2x plus 3 is less than or equal to 11, okay? That's the implication that you need to know with this particular problem. But I don't have to write it as two separate things and solve two separate things because they're all being modified in the same way. So what I'm going to do is I'm going to subtract the 3 in all three spots. So I'm going to get negative 10 is less than 2x, which is less than or equal to 8. Then I'm going to divide out the 2 everywhere. That's going to give me negative 5 is less than x, which is less than or equal to 4, okay? So, graphing that, I've got my number line. My numbers of interest are negative 5 and 4, negative 5 and positive 4. And I've got x is greater than 5, goes this way. And I've got x is less than or equal to 4. Less than or equal to is a closed circle, less than to the left. And since it's an and, I want to know where they overlap. So the overlap is in the middle. So that's my true solution set. So the number line here is going to be from negative 5 to 4. An open circle at negative 5, a closed circle at 4. I'm going to connect the two together. Okay, so that's my final answer for problem number 9. Problem number 10, I'm explicitly being told that there's an or, and there's no shortcut way to write or. You will see the word or written there, okay? So now I just want to solve the two independently and then graph the or solution. So I'm going to subtract 1 from both sides to get negative 4x is greater than 6. I'm going to divide out negative 4. Because I'm dividing out a negative, I need to flip the direction of the symbol. 6 over negative 4 is the same as negative 3 over 2, or negative 1.5. Decimals are fine as long as you're not rounding those decimals. All right, and then I'm going to solve the other, which is 3x minus 3 is less than 5x. I'm going to subtract over the 3x to get negative 3 is less than 2x. Divide out the 2. And I'm going to get x is greater than negative 3 over 2. So it was the same number twice. Let's see what the graphs look like. Oh, it was the same number twice. I don't need two different numbers. I just need one number. Oops, that should be green. Negative 3 over 2. All right, this is going to be a little confusing, so I'm going to color code this. This inequality, x is smaller than negative 3 over 2. Smaller than, to the left. No equal to. And then another color we'll do purple as a good contrast. For this one, I've got x is greater than negative 3 over 2. X is greater than negative 3 over 2. And it's an or inequality. If I can graph it, I can keep it. So here I have everything to the left of negative 3 over 2 works from the orange. Everything to the right of negative 3 over 2 works from the purple. The only number that doesn't work is negative 3 over 2. Okay? So my final answer here is going to be all real numbers except for negative 3 over 2. So I'm going to draw a smaller number line here with my negative 3 over 2 marked. I'm going to have an open circle and arrows pointing in both directions. Okay? There are a lot of special cases when it comes to these compound inequalities. I'm sure it's something that we will discuss before you go ahead and take your first assessment. All right, if you have any questions, let me know. Good luck.